Hey everybody, in this video I'm going to take apart this Campagnolo branded bottom bracket. There's a reason why I said it's Campagnolo branded and not, hey, this is a Campagnolo bottom bracket. There are actually very few components made by Campagnolo. In fact, this may only be the sticker that's made by Campagnolo. Let me explain. I'm going to show you the parts, I'm going to show you what's important and how this comes apart. This assembly is made of a shaft in the middle, a snap ring at the end here, a big bearing, a spacer, two smaller bearings, and another ring, a retainer ring here on this side. When the components are taken apart, they look somewhat like this. This is the shaft, which is hollow in the middle. They may have design variations. It may be thicker in the middle or thinner on the middle. This is an older design, this is a newer one, I believe. The assembly has a definite asymmetry, meaning the left side bearing here is wider and larger in diameter. Those are smaller ones, so it does matter how the components all go back together. When you get replacement bearings, it's important that they be placed on the proper side. So you can see that this snap ring goes into the groove. You can see this groove clearly on this surface here, machined into this forging. So Campagnolo may not make these forgings, they may not do the machining on it, because the fit of the bearings, these surfaces here, the bearings are friction fit on the shafts, and it's a precision fit. Alright, Campagnolo may not do it. This spacer here in the middle, in this case it's a single metal tube that's flared out on one end. For assembly it's important that the flared end is facing the big bearing and the small end faces the two smaller bearings. Fairly straightforward, yes. I have another variation of this spacer that looks like this. This is a carbon fiber tube or pipe with two end caps that are also very nicely snug precision fit. So that's one end cap. Here is the other end cap. And Campagnolo might have access to carbon fiber like this, and they might cut this one to length. I really don't know how much their manufacturing involvement is, but Campagnolo does not make for sure the bearings on the assembly, okay? Especially that the bearings are labeled SKF. SKF is a bearing manufacturer. This is how the big bearing looks like. You can see the SKF letters clearly printed there. I think, and this is my guess, I think SKF is a Japanese bearing manufacturer, and for sourcing out your replacement bearing from your bearing supplier, this seal comes out and the bearing designation is printed on the seal. The size of this bearing is 6903. RS relates to the material of this seal, and that it's a single seal only, it is not double sealed. And I washed everything in solvent, and this is why it's necessary to replace these bearings. Just listen to it. It looks like or sounds like that it's running perfectly and smoothly, but that's not really the case. This one has developed a definite play, axial play this way, sideways. I'm twisting it sideways like so. I don't know, 1/10 of a millimeter, some small amount. It's worn. Bearings, it doesn't matter what brand bearings, but bearings are rated in number of cycles. This would be one cycle. So they're rated for 1,000,000 cycles, or its lifespan could be 10 million cycles, whatever, it's a number. 10 million rotations on the cranks does not necessarily turn into mileage, because it completely depends on what size of wheel you have and what gears you are in. but as the bearing manufacturers go, 1 million rotations is typically specified for a bearing's life expectancy. So if you add up if you look at your cadence numbers, that's gonna give you the closest estimation of how many cycles you have on your bottom brackets. So it's not mileage, look at your cadence numbers and look at how many hours of operations you have on your bottom bracket. Say if you traveled 100 hours, not in a day, not in a week, whatever, just a total of 100 hours of operation at a steady, just work with me on this one, 60 RPM, the pedal goes around 60 times, like so, from 12 o'clock position, goes down, comes up. Okay, so that's rotation 1, rotation 2. So you have a pace of 60 RPM or a cadence of 60. 100 hours of operation will give you 60 times 100, 6,000 rotations. Okay, so it's gonna take a while to reach a million, but let me show you what's inside, how the surfaces look like when they are destroyed. This is the inner race of one of these bearings that I took apart, and you can see the surface here appears to be rippled. Let me just get you a nice sharp picture on this, give me a sec. I'm working on it, working with the light, thereabouts. So in the middle, in the groove, is where the rolling elements roll, so they look shiny and polished and nice there, no problems there, no loss of metal there. And then there's the rippled surface. Okay, it's pitted, chunks of metal are torn out and missing from the middle of this race, right there in this section. Okay, so that's what happens. This loss of metal makes a higher rolling resistance when you turn over the cranks. These bearings need to be replaced after a while. 1 million rotations typically. Okay, so that's that. So the bearing designation comes from 3 measurements: inside diameter of the inner race, outside diameter of the outer race, and the thickness of the bearing. So this bearing here is 6903, and I'll show you the other numbers on the edge of the inner race there. Let me just get you a nice picture here. There we go. So it says 6903, that's the number you need. It also says SKF and other numbers as well. And there, 61903-RS1 is also printed on it, and that one is an S1 or 5-1 at the 3 o'clock position here, and it also has those numbers printed on the inner race. So those are maybe nice to have just in case you need a replacement, and the bearing distributor needs more numbers, but they should be able to give you a bearing if you tell them I need a 6903 bearing sealed on one side with a rubber seal, or not a metal seal. Okay, it has to be kind of rubbery to keep the water out. 6903 for the big one, and for the smaller bearing, which is on this side, and they kind of sometimes tend to come out like this because water enters on this small side. I don't know why, but this is the bearing designation number printed on the seal, 6803. So you have 6903 from the other one, from the big one, 6903, and this is 6803, and both of them are RS, meaning the seals are of the same type and are on one side only. And oops, and I can show you that this smaller bearing here, the 6803 smaller bearing, this one is in okay-ish looking condition, but this one completely collapsed. The bearing elements and the cage inside, everything is collapsed, that's why it's moving this much. This one is SKF bearing, again not made by Campagnolo. There it says SKF right in the 12 o'clock position here. SKF France. I don't know the last time SKF bearings were made in France, but this is what's printed on it. And some other smaller numbers that you saw on the inner race of the bigger bearing, but those are not the designation numbers. The designation number is the 6803 that was printed on the seal. Alright, let's get to work. I'm going to take this apart. First one, I'm going to take out that snap ring, and that can be attempted with a chisel or whatever. I'm going to go with a snap ring remover tool that kind of lifts the back end of the snap ring away a little bit, like so, and then if I work around it from the raised point there towards the end of the snap ring, it can come out of the groove like so, or it will come out fairly easily. And of course everything is dirty, so get ready with some rags. And the tools that you need is a screwdriver. I'm gonna use a cold chisel like this, and a fairly small hammer. Okay, just like so. It's a small hammer. So the snap ring comes out like so, and is not destroyed, is not in the process of removal, so this can be reused. There's nothing wrong with the snap ring. It's a tight fit, everything is a tight fit. So there, it's good to go for parts washing, basically. I'll show you. Snap ring round this way in cross section, so it's not flattened or anything, but it's spring steel. So that's, I don't know, I put it there, why not? Now we need to take off the big bearing. The big bearing is of course friction fit onto the shaft and needs to come off in this direction, and it's gonna come off by tapping on the spacer's edge. That tapping will be done with this cold chisel, just ever so carefully, like so, because I really don't want to destroy the surface edge of the spacer, like so. It doesn't need huge taps or huge bangs, and yes, I'm working on this piece of chunk of wood which is wobbly, sorry about that. So the gap is opening, this bearing is being pushed out. I'm going around in a circle, and admittedly this cold chisel is not the best tool for tapping on the end of the spacer. If you find a pipe that fits over it and catches the lip of this, that would be better to spread out the pressure, because the edge of the cold chisel will dig into the spacer a little bit. You can see I'm progressing, yes, so it doesn't need excessive force. I'm trying to minimize the tool marks in the edge of the spacer there. It was perfect before I started, just like this side is perfect, yes. So because the spacer is not a structural component, it just needs to be between the two bearings, so, and it's not rotating or it's not really, it's not a structural part, but it's important that it be there as and not shorter preferably than it was when you started. So you might be tempted to, hey, I'm gonna just sand down the surfaces, whatever. Sure, with a 600 grit sandpaper or 200 grit sandpaper, yeah, sure, for, you know, on a plate glass, yeah, sure, 5 passes or whatever, a few passes, not sanding it for 15 minutes, no. So, because this smaller bearing has completely collapsed, now it's kinda in the way and is quite annoying, but I'll keep tapping on this. Just a few taps should get this one there. So what's inside here? That's the bearing cage that used to hold these bearing balls. There, some are embedded here and there. Okay, so you can see this is this greasy stuff here. Water gets into the bearing, and what you see is the dissolved steel, the dissolved iron deposit being deposited back or embedded in the grease. More of this bearing cage material looking like this. So that's why 1 million cycle, that's the bearing's life expectancy. There's one tiny bearing ball there, and some more on the inside of this spacer. Let's look at the edge of the spacer. Let's see what the damage is. Thereabouts. So there. Alright, so this surface finish that resulted here is not ideal, but importantly the spacer did not get shorter as it was. And let me just get a plate glass here. There. Okay, so this is a sheet of float glass with some 220 sandpaper in strips glued to it, and for just touching up on this surface, that's about done. That's all it ever needs, just some light I kind of don't want to call it sanding, but that's how the surface looks like. Let me just focus the camera. Alright, so there are still some of those bearing balls stuck inside, but the surface here at the edge, the chisel marks did not disappear from it. I'm not trying to remove my chisel marks. I just made it so it's not sharp. That's all I did, and that's all it ever gets. Now I'm gonna put this on the ground there, and these ones next too, and then we have some more bearing balls there. Okay, and of course all of them are trash. And I'm gonna put them on this lid here. Now, the only reason why I do this, because I don't want to step into them later. Some of these bearing balls don't roll around because they are they have been sheared in half. Okay, this is what I have in mind. Just work with me on this one. There, you can see these bearing balls are worn away so that they are sheared. It looks like they sheared in half, but they actually wore away. Half of they got stuck somewhere, and as the rotation kept going on, the half of them wore away, and that's why these don't roll anywhere anymore. That one does. Okay, let me just put all this trash here on this lid. Yeah, sorry about the weight. And that one. Alright, let's have a look-see on this Biggie SKF bearing that looks like this. Also, water got into it, that's why it looks disgusting as is. This also seems to be an SKF bearing, with of course the same bearing designation. So let's have a look-see. (6903) RS, whatever, the rest of the numbers are the same. Another piece of metal shrapnel. Alright, and now for the last remaining bearing, tapping is gonna be going the other way around, of course. And because I really don't want to destroy the spacer anymore or stress the spacer anymore, this bearing is, which I see this also catastrophically failed. I see. Alright, I'm just gonna bust it off as is with the cold chisel. Which way should I go? I'll go down this way. Although they are fitted from this end, but this has collapsed, and it really doesn't matter. There's nothing to save. There never was. A worn bearing is a worn bearing, and more metal stuff. Alright, so this is just gonna come off like so. Oh, there's a seal. I'm gonna try to save the seal just for show and tell, not for anything else. The French SKF bearing. Let's see. There. Throw some sparks. More of these bearing balls drop out. In the same condition, I can feel they are flat on one side, whatever. Sorry about that. This is the same. This is the condition of this bearing cage. Wonderful. So there's nothing that's immediately visible on this outer race, but just checking the surface, if how the surface looks like. Yeah, we can look at that one. Okay, I'll show you how the surfaces look like. Same rippled, or there at the 6 o'clock position there, you can see the surface there being gouged out down there. Otherwise the surface inside the groove looks reasonable elsewhere. Yeah, there's another of that rippled appearance there. So, and I have these small metal whatever flakes on my finger and everywhere here. The seal comes out like so. And the seal, of course, is just a throwaway. You're gonna have the new bearing with the new seal on it. Let's see, any number on it? None. This one doesn't have any number on it. Okay, yeah, there's nothing, yeah, absolutely nothing on it whatsoever. No letters, no anything. Now what do we do with the bearing races still stuck on the shaft, and there's a ring in front of it. You can see how this looks like up close. You can see the gouged out bearing race here, especially on the inner one. Okay, so how this is gonna come apart is straightforward. I'm gonna hit this one off in this direction, tapping it a little bit, but I'm not gonna make you watch it, but it's gonna come away like so eventually in a few minutes, just like the previous